Think you're special? One of a kind? We agree. The way you pursue your digital ambitions is unique to you. And so is your appetite for digital risk. Whether you're hyperconnecting your ecosystem, empowering a distributed workforce, rapidly leveraging cloud, IoT, AI, or other new technologies, RSA is here to help you manage digital risk your way at every stage of your journey. So go ahead. Be you.
Hello, and welcome to Cyber Espionage, targeted attacks abusing third-party cloud services. If you're joining us live, our speaker is in the Slido chat discussion area, answering your questions right now. For audio or video issues, click the technical support button below. I'd now like to turn it over to Jaromir for the presentation.
Hello. So this is outline of my presentation. So in the beginning, I will tell you a short introduction about the general comparison of two kinds of malware infrastructure, which we can see in malware. It can be the custom or cloud-based. And after this quick introduction, I will talk about several APT cases which abuse the cloud-based infrastructure. So the idea of using cloud services and abusing these services in malware is not new. There have been some presentations in the past and some research done in the past. However, this talk will be special because we will focus on abusing of cloud services in context of targeted attacks. So the goal of my presentation is to show you several real examples of the real APT threat attacks. And then we will see what it means for us as researchers or defenders and how can we leverage or use these cloud services for our benefits. So now let's quickly review what is custom malware infrastructure. So in this case, the malware developer, they develop basically everything by themselves. So they register domain names, they prepare their own hosting, they just develop their CNC communication protocol, they develop their own backend services, backend script, control panels, they install and maintain their own CNC servers, and so on. This approach has some advantages. So basically they can implement whatever they want, whatever they like. They are not limited by almost anything else, but this approach has some disadvantages. And especially it might be easier to monitor, block, or sinkhole for researchers or law enforcement. And there is also higher probability that these developers make a mistake, make a vulnerability, and their backend service can be hacked, and basically they can have some problem with their service. And also there might be problems with reliability in different conditions, problems with overloading, and so on. So what are the cloud malware infrastructure? So we can have some malware which don't develop their own infrastructure, their own backends. However, they rely on knowledgeable third-party services. And these services can be very known services, for example, for file sharing, for text storage, for communication and collaboration tools. They can be different publishing platforms. They can be for example, some content formatting and feed aggregating tools, and so on. They are usually free, or if paid, very cheap. They use API for communication. They have much higher reliability. And these kind of services are harder to block, because if you block some of the legitimate service, you also block usage this service from use of legitimate normal users. So these are the advantages. As a disadvantage, that we would mention that these malware developers are limited by the cloud service APIs. So this was a very quick introduction, and now we will look into selected APT cases, which I helped to research in the past. So I will mention 4 different APT groups. For each group, I will show this kind of map, and this map shows the targeted countries. We should remember that these threat actors, they are APT groups, they're targeted attacks, so they are interested in espionage. So they mainly target various high-profile companies in different industries, and very much all of them like hacking, or all of them like getting into the systems which belong to government, because governments might have interesting documents from them which might get exfiltrated. So for example, this Patchwork group, we know that it's based somewhere in South Asia, and you can see that it mainly targets countries in Asia. You can see like Pakistan, China, Bangladesh, Sri Lanka. Let's name a few of them. So from this threat actor, I chose this backdoor. This backdoor is called Bad News, and this is how it works. So we have the malware in the middle, and it sends the GET request to some legitimate like services like Feed43, GitHub, or WordPress. Let's name a few. It returns the encrypted communication. It returns encrypted configuration. This configuration gets decrypted. It reveals the real CNC server when the real communication with the CNC server starts. So if we analyze the malware, we can see that it's an executable which contains the following strings, which start with I, UU, QT substrings. When we decode it, so it means that decoding in this case is subtracting value 1 from each character, we get the URL addresses as you can see below, like in the screenshot. Like one link goes to GitHub user content, the other one to Feed43, the third one to WordPress, and so on. So basically, when we visit any of these websites, we always get something like this. There's always like some long string which doesn't make sense in the beginning, but when we reverse engineer the malware, we can find out that this is base64 encoded string, which later gets decrypted either by XOR or bit rotation functions, or with some specific functions like encryption functions like Blowfish, and this leads to decrypting the actual CNC server address. Because it uses GitHub, so we can use GitHub for searching similar files. So we know that in this case, the file name was xml.xml. So if we search for similar XML file, we can, for example, see what is the history. So every time the file was added, we can get different configuration. So we can get different IP addresses or URL addresses, or we can also search for similar repositories in GitHub. So for example, in this case, we got 64 cases with the same xml.xml file. Each of them may contain the configuration, which can lead us to know more about the victims and get more information about targets and about another campaigns, which this threat actor has done. Let's continue with another threat actor. We call him Confucius. Again, based in South Asia, but this time you can see the highlighted country is just Pakistan. So they, for some reason, target some organizations in Pakistan. And from this threat actor, I selected a few stealers called Swiss Knife. And these stealers look like this. So they use another legitimate service. In this case, it's Dropbox, but it can be any other like cloud storage service. And this tool searches for files with specific file extensions. And every time this file extension is found, it gets uploaded to this Dropbox storage. And as you can see, we need for uploading, we need some configuration, some authorization variable. So what it means for us. So this malware, as we found out, was written in Python. So it was quite easy to decompile it. And after the compilation, we could see that in the beginning, there was like one variable with content, and this content is API key. So this API key is used for communicating with the Dropbox storage. Below is the code for searching, enumerating all the files. So we just looked into the documentation. We know that, for example, for Dropbox, we can get Python libraries. We can write this kind of simple code by ourselves. There is the function called files_list_folder. It has several parameters. And we are, for example, very interested in fourth parameter, which is called include_deleted. By default, it's false. But when you enter the value true, we get this kind of information. So even though that in this storage we found no data, no files, we still were able to retrieve some metadata. So by knowing that for each victim, this malware creates new folder, so we can list all the folders, so we could know like how many victims have there likely be, and also we could enumerate files which existed. So we could see like what kind of file names were exfiltrated from infected machines. So this was like one version of this Swiss knife malware. There was also another one for another service called pCloud, which was very similar. In this case, there was no API token. There was just login and password. So again, we can go search online. We can see that there are again some libraries in Python. So this is like from their GitHub page. There is also like example that we can, in these 3 lines, as long as we have the credentials, we can just write very simple 3-line code, just run it, and get the content of the files which have been stolen and uploaded there. So after this malware was again written in Python, after the compilation, we could see in the first line there was some email address and some password. So we had credentials, and even in case of these services where we have name and password, sometimes it's even possible to log in and see if there are any files which threat actors leave there. Yeah, this is also, there's also like in the web interface, there is also restore function. So if some files have been deleted and moved to trash and not removed permanently, they can be restored. So this threat actor also has malware under Android, some kind of mobile malware. One of the piece of malware is called TweetyChat. It was like backdoored Android chat application. So in this case, it was kind of like a hybrid approach. So there was the communication with like standard CNC server, not cloud in the beginning. But then there was also like one of the commands, received commands, was updating AWS credentials. So for uploading stolen files, the CNC server had to send access keys, and these access keys have been used for uploading bigger files into AWS. Yes, so we need like 2 keys, so AWS access key and AWS secret keys. Both of them have been sent to the malware from CNC server via cloud messaging, either Google Cloud messaging for old samples or newer Firebase cloud messaging. These are like screenshots of the code. The upper screenshot is the code of cloud message receiver, and the code below is just, it calls function put object request, which basically uploads the object to Amazon S3 bucket. So let's move to the third threat actor I would like to talk about. It's called Muddy Water. And as you can see in the map, there's lots of red color in Middle East. So this threat actor is based in Middle East, and they like to target all or many countries in the Middle East. So from this threat actor, the first backdoor I chose is called CloudStats. This backdoor uses again Dropbox, but in a different way. It uses Dropbox or cloud, or it can use any cloud storage, but it can use it in a different way. It can use it as command and control channel. So in this case, when the victim gets infected, it computes some unique hash, and this hash is the name. It serves as a name of this machine. So it uses this hash and adds the extension. And the extension, in case of registering new infected machine, as extension .rec. So it creates .rec file in the cloud storage. Then threat actor monitor or malware operator monitors this cloud storage. And if he wants to execute some commands, he puts this command into .cmd file, uploads it to the CNC server. Then the malware reads this CMD file, executes it, saves the result into .res file, and uploads the result to the Dropbox again. Yeah. When we look at the source code, we can see something like that. So we can clearly see that this was written in PowerShell, And when looking in the code, we are interested mainly in this kind of information. Authorization variable, which I will describe later, and then URL address for downloading. For uploading function, we are interested again for URL for uploading, again, authorization variable, and content of the data, which should be uploaded to the storage. So what is the authorization, or what is the API key? It was hard-coded again in this malware. So you can see the variables $API0, $API1, so API1, so there have been like two hard-coded API tokens. So for us, it means that we can read this token and use it with our own script to monitor what's going on in this CNC channel. And this is a piece of code which shows the names of the extensions which I described before. Also, you can remember that there is like one more extension, .prc. So basically, it's like locally after execution, there is .prc, like the process result, which gets encoded and saved to the result file, .res, and uploaded. And these are two examples of .registry file or .reg file. So you can see there is the operating system version. There is the bitness, if architecture, 32 or 64-bit. There is like the domain name, IP address, time of execution, and the result file is hex encoded. And after decoding, it can look something like that. So the threat actor wanted to list all the files in the user's desktop. So it calls the command and gets this kind of result. For the muddy water, we will also mention like one more example. In this case, it's again Android mobile application, but in this case, it uses Telegram, but it's also hybrid approach. So it uses both standard approach, like standard CNC server for retrieving the commands, but for uploading bigger files or stolen information, it uses the Telegram channel. So when we look inside the malware, we can search for some piece of code which references to Telegram. So we can see in the screenshot above, there is the link to api.telegram.org, which follows according to documentation with bot token / there's the method name. So in the screenshot above, we can see the method name is send message. So we find something like that. When we look again into the function which processes the commands, it's named process command, we can see that there is a switch with several cases. You can see case 55, 54, 53, 52. And in two of these cases, there is the hard link to api.telegram.org / token and the method. And below is the function which gets executed. So you can see that there is function called get system info or get smart call log. So the names are quite self-explanatory. There is also like one interesting feature or one useful feature for the threat actor. There is basically once a day, the malware collects all the possible information like the system info, contact info, installed application info, call log, and SMSs, and sends them to the Telegram channel. This is useful if the threat actor for some reason loses control of the CNC server, and if this malware is still installed in the phone, in the mobile phone, it still gets once a day, it still collects all this information and sends it to Telegram channel. One interesting thing when talking about Telegram is that we can display the metadata about the Telegram account. And in this metadata, we are usually interested in username or maybe language code can be interesting for us. Because in this case, the user set the language to Farsi, FA, which might give us a hint like where the threat actor might come from. But of course, we always have to remember that this information can be fake, so it can be manipulated. So we shouldn't believe it all the time. Let's go for the fourth threat actor I would like to mention. We call it SLUB, and it's interesting, or this threat actor has some interest in North Korea. And this case is, I would say, the most interesting from all these cases which I mentioned today, because I will talk about two versions. In version 1, it uses these three different cloud services. So the first one is GIST for requesting commands to be executed. The second one is Slack, which is used for uploading or for sending the results of received commands. And in case that some bigger file needs to be exfiltrated, it uses this file.io service. So we know that this malware has been delivered via waterholing on one website, which was about or related to North Korea. When we observed these GIST snippets, we saw something like that there is this gist file 1.txt, and there is the list of commands, which are quite self-explanatory. And these commands, they can be activated or deactivated. So if the command is activated, so it starts with these two symbols, this caret symbol and dollar symbol at the end. And for example, in this case, we can see that capture command gets executed. So it means taking the screenshot. Task list is listing of running processes. Drive list is list of disks. And file list is list of files in a given directory. For Slack, we, again, similar to Dropbox and pCloud and others, we need to have token again. And this token is hard-coded in the binary. And this token is split into smaller strings. So we need to take these strings, concatenate them together. And this is what it will be our token for communication. And exfiltration files to file.io, it's very, very useful, because once the file gets uploaded to this service, after the first download, after the threat actor downloads it, this file gets automatically disabled or completely deleted. So basically, it's like one-time storage for the files. Later, we have seen version of this SLUB version 2, and they made one change because they stopped using this GIST GitHub. They didn't use it anymore because the previous solution had one problem, that there was only like one GIST repository, and it was executed on all the victims at the same time. So instead of that, in version 2, they use the Slack for sending and receiving the commands. So for the Slack, if threat actor wants to execute a command, they write a message and pin it to the channel. Then the victim machine reads this message, executes it, and sends the result back to this channel. Yes, let's see it in the schematics again. So Slack, again, is for communication, for communication with, yes. File.io is for uploading stolen files. And there's like one more feature using this microblogging service called pen.io. And it is used for updating Slack tokens. Because we as researchers, if we find some tokens which are abusing the service, we can report them, and these cloud companies can disable these tokens. So for the threat actor, it means that if these tokens get disabled, they would lose access to their malware, to their infected machines. So they implement this kind of fallback. So if their tokens get disabled, they can use the service for updating the tokens. So the malware regularly reads from this website. This is how the website looks like by default. But if a threat actor needs to update their tokens, they can change the content of this address. So below you can see there are new tokens. So malware reads new tokens and resumes its operation. Yes. For us as researchers, it's quite interesting that when, for example, there is GIST, we can always see what revisions, what changes have been done, so we can have some history. when using Slack API, there are like Python libraries. So when we have the token, we can call various commands like list of users, information about the team, a list of channels. And the most interesting and important for us is the last line, which is called channels.history. So it can give us a history of messages in the channel. And when we ask for the history, we can get this kind of result written in JSON format. And you can see that there is attribute text, and the text is the command which has been executed by the threat actor. So we can know like which files they were after and which directories they wanted to enumerate, what they were interested to do. And also for taking screenshots, we were able to find some permanent links to the screenshots, which could be again downloaded with wget or in anything else. Yeah, so now we come to the conclusion. So the abusing of the cloud services is a worldwide trend, I would say. These services can be abused for different purposes, either for storing the configuration or uploading the stored data, or it can be used as CNC channel for sending and receiving messages. It has some benefits for us as researchers because in many cases we don't need to hack back. For us, having just or extracting the token is enough to monitor the threat actor and to get some information about whom they are targeting, what information they are interested in. And for the takeaway slide, I would say that we should remember that all the traffic for these cloud services is encrypted. So it's basically impossible for us to distinguish which traffic is legitimate and which is malicious. Blocking IP addresses or DNS blacklisting is kind of limited because if we block some of these services, no one can use it, neither threat actor nor the legitimate users. We cannot take down these services. However, it gives us like very good possibilities for monitoring these attackers. We can search for similar campaigns. If we find on these services like another campaigns, we can know like some other targets. We can display the history, version controlling, and it can help us to monitor the attackers like much better and much easier. So now we came to the end of my presentation. So if you are interested to read more, there are like some blog posts or research papers I helped to write in the past. So if you are interested, please follow any of these links. Thank you for your attendance.